Hi, welcome to the Olympiad geometry. Let's continue our study on the Simson line theorem. Here's the problem. L does not intersect with circle O. E is on L, and OE is perpendicular with L. M is any point on L except E. MA and MB are tangent from M to circle O, and AB are tangent points. EC is perpendicular with MA on C. ED is perpendicular with MB on D. CD intersects OE on F. Show that F is independent on M. This is a very interesting problem. It's a hard one, to be honest. So let's break it and try to solve it step by step. The first thing that we are noticing is that MB and MA are tangent of the circle O. So from the experience, we should just connect OB and OA. Right, that's how you get more information from a tangent line. We got the perpendicular relation here. And we know that EC is perpendicular with MA, right? ED is perpendicular with MB. So that just reminds us the Simson line, right? So it looks like we want to prove, right? Because EC is perpendicular with MA, that means MA is an edge of a triangle. And ED is perpendicular with MB, that means MB is an edge of a triangle, of the same triangle, which means we have MB, MA, so we have a thought that maybe MBA is the triangle we're looking for, that E is on the circumcircle of the triangle MAB, right? So in that case, EC perpendicular with MA, ED perpendicular with MB, and we find another line that, for example, EH perpendicular with AB, then CFH would be the Simson line, right? But all of these can be valid only if MABE is a cyclic quadrilateral, right? So we want to basically, from here, we want to prove, or we have a thought, we want to see whether MABE is cyclic. So MABE, so just think about that. If MABE is cyclic, right? Because MBA already define the circumcircle, right? E is just on that circumcircle. So we can think about what's the circumcircle of MAB. Let's connect AB here. What's the circumcircle of MAB? Because OB is perpendicular with MB, and OA is perpendicular with MA, which means angle OBM is 90 degrees, and angle OAM is 90 degrees. So if we connect OM, it would be very clear that OM is the diameter of circumcircle of triangle MBA, right? Actually, MBOA is cyclic, right? This is a diameter, so that's why OBM is 90 degree, OAM, angle OAM is 90 degree, right? So we know that OBMA is cyclic, which means we just need to prove that E is also on this circle. And it's obvious because angle OEM is also 90 degree. Right, so because angle OEM is 90 degree, which means OBEMA is cyclic. Right? Now we just finish our first step, that we prove E is on the circumcircle of triangle MAB. So from here we know that we have a perpendicular line that EC is perpendicular with MA and ED is perpendicular with MB. So we extend BA. Right, and we do for example, here is EC, ED. This is F, so let's call it G, right? So we know that EG is perpendicular with AB and GF, based on the Simson line theorem, that GFC are collinear. Right? GFC are collinear and EG is perpendicular with AB. Right, that's what we get so far. And we want to find the relation of EF. That we want to actually show that F is independent on M, which means F is a point that only dependent on the radius of the circle O and OE. Right, so F should be a point that only dependent on radius of circle O and OE. So let O circle O radius, right? We set it to be R, and we set OE equals to for example here we set it to be a distance S, right? So we know that OB equals to OA equals to R and OE equals to S. Now let's see what else we can find. We notice a point here that is intersection point of OE and AB, right? What's the thing unique of this point? Because let's call it to be, for example, Q. What's unique of this point? Because OM is OM is the diameter of the circumcircle of triangle AMB, right? And because MB equals to MA, which means B and A are symmetrical to OM, which means BA is perpendicular with OM, right? And in the triangle O, let's call this point to be N, right? In the triangle ONQ, we know this angle equals to this angle, right? And so let's compare the triangle OQN and the triangle OME, right? Because they are right triangle and they are sharing the angle QON, right? That means the right triangle OQN is similar to right triangle OME. That is clear, right? So based on this, we know that OQ to OM equals to, see here, OQ to OM equals to QN to EM equals to ON to OE. Right, we got this. So from here, we know that OQ times OE equals to OM times ON. Right? OM times ON equals to OQ times OE. And because triangle BON is similar to triangle MOB, right? This triangle is similar to this triangle. We're trying to find the relationship of ON and OM, right? So we can see that ON divided by OB equals to OB divided by OM, which means ON times OM equals to OB squared, that's R squared. Right, so based on these two equations, we got OQ equals to R squared, that's OM times ON, R squared divided by OE. And we've already said OE equals to S, so R squared divided by S. Right? So now we know that OQ is a constant, right? Q is a point that independent with point M. So when we want to find that F is also independent with M, we just need to find the relationship of F and Q. That is very straightforward for here. So look at F and Q. They are all in the triangle a right triangle EGQ, right? FQR in right triangle EGQ. Now let's think about it. Because this is a let me draw it. So because this is 90 degree and this is 90 degree, right? So EGAC is cyclic, right? This is 90 degree and this is 90 degree, so EGAC is cyclic quadrilateral, right? Because this plus this is 180 degree. That means angle angle AGC, so AGC here, this angle equals to angle AEC. Right, because EGAC is cyclic, so the same arc AC reference to the angle AGC and AEC. They should be same, right? AEC. And because AOBEM, right? AOBEM. AOBEM are on the same circle, which means this angle EAM equals to angle EOM, right? Angle EAM equals to angle EOM. So this one equals to this one. Now we look at these two things here. The angle AEC here, angle AEC plus angle EAM equals to 90 degree, right? Because this is 90 degree. So it's right. Angle AEC plus angle EAM equals to 90 degree. Then we got that angle AGC plus angle EOM equals to 90 degree, right? The angle AGC plus angle EOM is 90 degree, right? And we know that angle EOM plus angle OGM is 90 degree. We know that angle OQN plus angle EOM equals to 90 degree. Right. So from here, we know that these two angles are 90 degree, and we know this equals to this equals to this. So these two angles, the sum of these two angles is 90 degree. And we know that this angle plus this angle equals to 90 degree. That follow me, that AGCA, we already proved that angle AGC plus angle EOM has to be 90 degree, and we know that angle OQN plus angle EOM is 90 degree, right? Because the angle ONQ is 90 degree. So from here we got angle AGC equals to angle OQN, right? AGC equals to OQN, and because OQN equals to GQF, so we know that AGC, which is QGF, right? QGF equals to GQF, right? So in the right triangle EGQ, we have F. Let's draw this like this. So this is E, this is G, this is Q, and F is here. Right. So we have that angle GQF equals to angle QGF. So we know that F is midpoint, right? Midpoint of QE. F is midpoint of QE. Because this is a right triangle, right? F is midpoint. So we already know the distance of OE, that is S. Right, distance of OE equals to S. And we just calculated that OQ equals to R squared divided by S. And we know that F is the center of QE, which means the distance of FQ equals to S minus R squared divided by S times 0.5, right? That's for the FQ. Or we can say OQ or OF equals to OQ plus QF equals to R squared divided by S plus S minus R squared divided by S times half, right? So this one. Let me write it here. I don't have enough space. So OF equals to half S plus R squared divided by S. And as you can see, it only depends on the distance of OE and the radius of the circle O, independent with the position of M. So this problem is not an easy one. I think it's on the level of IMO. But it's not one that you cannot find the way to solve. You cannot find the breakpoint, right? The strong indication here is that we find several perpendicular relation that all point to one that all related to one point E. So we're trying to find whether E is on the circumcircle of a triangle, and then we just need to find based on this we have some angle relations, and based on the angle relations we need to calculate for the OQ distance and figure out that what's the relation between F and Q. Right, once that's done, it's straightforward to see F is independent with M. So that's it. I hope you like this video. See you in next one. Thank you.